All right. Welcome back for those of you who have attended a Teen Science Cafe before, and welcome to anybody if this is your first time. My name is Lauren Traster. I'm the 4-H Teen and Leadership Program Coordinator and the person who facilitates these Teen Science Cafes. Let me just share my screen. I know we have some more folks still just coming on in. So what we're gonna do, if you all can open up your chat, I gotta open up my chat too. And let's see, I'm gonna get started here. Trying to do too many things with too many screens open. There we go. All right, so we really like to have everybody introduce themselves. First of all, I just put in the chat a link. If you do need our live captioning, just click on that link and you can have the captioning right there for you. But I'd love everyone to go into the chat, introduce yourself. Who are you and where are you from? That's what we like to know. Hi, Carly, Springfield. Lily's from Vermont. If you're from Vermont, tell us where in Vermont you're from. I am from Hyde Park, Vermont. We have Lexi joining us from Shelburne. And Lily's from Waterford. Fantastic. All right, I know we still have some other folks coming on in, so keep introducing yourselves as I just go through some of our welcome instructions. So if you can open up your participant list, your name's going to come up at the top. Can you please make sure your name is showing up as who you actually are, because we do check it against the registration list. And that way I don't have to bother you during the presentation to be like, who are you? Tell me your name. So if you need to rename yourself, on your name, there's going to be an option to rename yourself, and then just make sure you show up who you are. We greatly appreciate that. So moving ahead, just want to remind everyone why we're in Zoom. If you can stay muted throughout the presentation, unless you want to ask a question or answer the presenter, we just ask that you raise your hand. Don't raise it in the video because we can't see everyone at the same time. Again, if you open up the participant list, one of the options will be to raise your hand, and then we'll call on you and tell you to unmute yourself. We definitely want everyone to participate. The other way is through the chat. And I know that our presenter, Bryn, has a lot of ways that you're going to be engaged in tonight's presentation and ways for you to participate. So hopefully you're all up for that, because I think it makes the cafes way more interesting when you are participating. So just be courteous of one another, be respectful. If you do have your video on, just make sure there's nothing going on behind you that would be distracting for anyone. And it's also your choice to have your video on. So do it if you want to have it on. You're more than welcome to also participate with your video off. And then again, just participate. It's going to be a really good cafe. I've seen the slides. I'm very excited. So moving ahead, I do want to let you all know about some of the stuff that's going to be happening in the new year. We have some really good science programming coming up. So first off, there's going to be a whole month of engineering in February. February is engineering month. There's National Engineering Week that happens at the end of the month. And we have a lot of different programs that are connecting to that with the College of Engineering and Mathematical Sciences at UVM. So just posted in the last day, we have a Create Your Own Invention contest. And I will tell you, the contests and challenges, you can win prizes, and prizes is gift cards, money. So a little enticement there. But so the first contest is Create Your Own Invention. There's also a Rube Goldberg challenge. The Create Your Own Invention, that's a work by yourself. The Rube Goldberg challenge you could do by yourself, or you could get a team of up to total of 4 people on a team. There's going to be a huge event at UVM on February 12th, where there's going to be a morning where you can interact with different engineering businesses and student groups at UVM. And then the afternoon is a bunch of hands-on workshops, all connected to engineering. We just posted the Teen Science Cafe schedule for the winter and spring. We have a bunch of really good cafes, both in person and virtual, coming up. And we're also hosting another Learn to Code program. This time you're going to learn Python. So all of this can be done. And I know there's even more stuff that's going to be coming out, but that's all I could fit on the page. You can always go to this website, and I'll put that in the chat when I'm done talking. And that's where you can find out about all of these events. So, want to get to tonight's cafe. The topic for tonight is digital phenotyping, leveraging machine learning, statistics, and creativity to model human health. Our presenter is Bryn Lofness. And let me just tell you a little bit about Bryn before I turn things over to her. Bryn is a current PhD student in the Complex Systems and Data Science program at the University of Vermont. She works primarily within the MSense research group. A collection of research is focused on developing digital biomarkers and therapeutics for improving human health and performance. She also works with the UVM Neurobiotics Lab and remotely with the Sabeti Lab at Harvard through the Broad Institute of Harvard and MIT. Bryn completed her Bachelor of Science in Computer Science from Colorado Mesa University, summa cum laude, which means she was at the top of her class back in December 2020. And Bryn's individual research topics relate to stress detection and community health analysis. So let's all welcome Bryn, and let's get ready to learn about digital phenotyping.
Great. Thanks for having me here. And thanks, Lauren, for that great introduction. I'm super excited to chat with you all today. And just as I'm sharing my screen quick here, I want to let everyone know that I really want to make this a super interactive discussion today. I want to make sure we're just chatting, we're having a good time. Everyone can kind of, can everyone see my screen okay also? Great. And we're going to have some polls, and at any time, like Lauren said, feel free to raise your hand or just unmute and say whatever question you have. I really want to make sure that we're just having a conversation. So like Lauren said, thanks again for that introduction. Today I'm going to be discussing with you digital phenotyping. And the main thing I want you to get out of this title is how we can use creativity to model human health. So there isn't just one way of analysis or one way of using math or computers to solve the problem that is, how do we analyze human health? There's a lot of creativity that goes into that. So let's kind of get into it. So just a little bit of background. Lauren already did a great job in giving a small background, but I'm born and raised in Minnesota. I just moved here to Vermont. In my free time, I like to do art. I like to do some traveling. I like to be active and do some sports. I also work with a variety of research groups here in Vermont, as well as over in Cambridge. And then I also have my own business. And so if you guys have any interest in research or interest in talking to someone who's done research, I definitely can answer any questions you might have at the end, but also about industry related things. So let's kind of dive in here now. I'm really excited to kind of just see what we can chat about. So the first thing I want to do here is I'm going to start a little poll. And if you guys can guess, I'm sure you may not have heard what digital phenotype means so far. And so I'm just going to kind of start that poll and just see what you guys might think it means. And if you don't know, that's totally okay. There's no wrong answer here. We're just getting started and I haven't explained anything yet. So if everyone can kind of see that, and you can participate if you want, I'll leave it open for, another 30 seconds or so.
So Bryn, the poll cuts off the words and then you can't see the slide. So I'm wondering if maybe, if you can't, I'm wondering if we can just put it in the chat.
Yeah.
Does that make, oh, I see. Actually, if you move your mouse, you can read the full description. If you hold your mouse over each option, then you can
Oh,
see
yes,
the
yes, I'm
full.
seeing that. You don't even
Okay.
have to click on it. It's just kind of,
Okay,
yeah,
you all
that's cool.
maybe just figured that out before I did, but I'm like, I can't read the slide now because the poll's in the way and I can't, but yeah, if you put your mouse, you can see the full definitions.
Great. So it looks like we have a few responses here, which is totally great. I'm just going to end that poll. And there were some good kind of guesses here. Mainly people guessed is it an electrical engineering subfield that focuses on analyzing, modifying, and synthesizing signals of genetic importance? And it's not quite that. It's actually, let's move to the next slide here. Digital phenotypes can be thought of as a personalized digital image or model of health metrics, outcomes, and behavior. So it's kind of similar to that signal processing one that some of you guessed, but it's less with genetics and more with, how are you interacting with society? What's your behavior like? What is your heart rate like? What are those kind of metrics that we can capture about you and kind of create this digital image of you to understand your health over time? And so what that process kind of looks like is, as you guys maybe have or have seen many people around you, we have a lot of smartphones available. A lot of people also have wearables. I'm wearing one right now, a Fitbit. Some of you guys might have one. Some of you might know people that have an Apple Watch or Fitbit. We've got a lot of different devices around us every day that are collecting a lot of data. And how we use those to kind of better monitor our human health is what digital phenotyping aims to do. And so from these different metrics, we can identify different statistical trends. Let's say it's a certain time of year and all of a sudden my heart rate starts to go down and we start seeing that trend in, my mean heart rate every day, or my mean heart rate over the past month has gone down. You can kind of understand how we might want to use those trends to say, okay, what's changing in her behavior? Because obviously there's something happening there. And then we've tried and categorize similar users. Let's say a whole group of individuals are seeing decreases in their resting heart rate. What are those individuals changing in their behavior? Is there a certain subgroup of those individuals that are doing something similar that's causing their metrics to change over time? Can we somehow use that to our benefit of suggesting different health goals or activities that can help them specifically change their kind of holistic health status? And so that's the whole goal of making these clusters of individuals, is providing more personalized healthcare, because not every body is the same. Just like every person in this room, we all have unique bodies, we all have unique minds, we all have unique interests, but there's some things that make us similar and have some overlap. And how we can identify that is how we can provide, better health goal setting for all of us. And so that goes into finding those similar users' outcomes and trying to benefit them. And so breaking it down a little bit more, what is a phenotype? So this term, a lot of time, you might have seen it in biology class, but maybe not. But basically, just generally, it's the set of observable characteristics of an individual that results from the interaction of its genotype, pretty much the genetics of an individual, with the environment. So basically, how does your genetic makeup, how does who you are at kind of a molecular DNA level interact with the environment? So that's your eye color, your hair color, how you speak, how you walk, kind of your gait patterns. All of that stuff is less kind of nurture and more in nature. That's how you were born. That's how you were brought into this world. And so understanding that on kind of a more deep level, phenotyping doesn't just mean your eye color, your hair color, but it also can help dictate your personality and your behavior. And a lot of that is how you interact with your environment, but that's where phenotype really comes together with that environmental aspect. And so what is digital phenotyping? How did it come into play? So, phenotyping, it's observing those characteristics that we can see. But also your digital phenotype is, okay, let's say we've got all these digital streams, we've got a Fitbit, we've got your smartphone, we see you're doing these certain things, and how can we create that digital image? Well, this term was coined by Harvard's Onella Lab, And it's supposed to be the moment by moment quantification of individual level human phenotype. So basically, from each moment, how is your behavior changing? What is making you you, and how are you kind of showing that through signals that we can measure? Because the whole point is finding measurable signals, right? How are you sleeping? How are you interacting? Is there anything that's hindering your mobility about your environment? And how can we learn from that to make you a healthier human being? You can imagine if we were better able to understand these signals, maybe we'd be able to tell your doctor these things, or you'd be able to tell your doctor these things and say, oh, I've got an app that's saying I have these trends over time, and I'm very similar to these other users that have also these trends, and they've tried this to help with their this. You know, you can kind of see how you might be able to use those trends, just speaking very vaguely. So let's start going into, I've kind of explained, I've set the scene, you know, here's what we're talking about here, but how can we really visualize it? How can we give some context to what we're trying to learn about here, which is a new term that I'm sure not many of you all have heard about, which is okay. Like I said, it was just coined in the past couple of years. It's relatively new in the field. The research of it is very new. So how can we here in this Teen Talk understand it a little bit better and visualize it? So let's say we have 5 individuals. Just for ease, they're individuals 1 through 5. They don't have names right now. So I'm sure many of you through your classes or just through curiosity or, you know, your free time have taken a personality test, or you've heard of a personality test where your personality can kind of be, you answer a bunch of questions. I like to be treated this way, or I act like this in a group, or I'm this kind of leader, or I like to work alone in groups, or I like to be outside to really reconnect with myself. That's like kind of all part of your personality. And you take these tests to better understand, you know, different things about yourself. And maybe, you know, you're answering these questions that relate back to you, that only you can answer, but then they give you information that's a little bit more generalized based on kind of your cluster of personality type, but it's very much related to how you can relate to yourself and how you can be a better human. So that's one way to kind of create a, I'm going to use the term cluster, which is just, you know, your grouping, your kind of digital signature group, where in this situation, it's less a signature of your heart rate or your sleep patterns, but your personality type. And so here we can see the person 1 and person 4 have the same personality type. So what can we do with these clusters? Maybe person 1 and person 4 both like to be a leader in the group, and then they were just put into a group project, but they know about themselves, they like to be the leader. But since they know that about themselves, they can work together to find a good way to co-captain. And so that's one way you can leverage your knowledge about what cluster you're in. For this situation, it's your personality type to be a better group member. So that's just one example of taking digital phenotyping out of the health sphere, out of the statistics sphere, and more into something that maybe you've done yourself, which is take a personality test. And then let's kind of add an extra layer. You don't just have a personality, you also, you know, were born in a certain month. And I'm not super into astrology, but I'm sure many of you have heard of it, or at least looked it up, or maybe have read your horoscope once or twice. I won't ask who did it. No judgment. I think it's fun to do, right? But what does that say about yourself? It's just like a personality test where you answer questions about yourself. For an astrology sign, it's just when were you born? You know, what time, where was it? And you get to learn kind of these generalized features that maybe relate back to you and maybe can give you advice for how you should handle the day or handle your crush for that day, and if you should go talk to them, or if you're feeling confident and should start a new project, and kind of that advice on how you can be a better you, quote unquote, kind of. And the same thing with personality type, it's the same goal of putting you into a cluster where you can relate to others and give you generalized goals. And here, once we kind of layer in both astrology and personality type, we see that 1 and 4 not only have the same personality type, but also have the same astrology sign. And so maybe they're even more similar than, let's say, A1 and 5 that have the same star sign, but don't have the same personality type. And so we can learn from these different categorizations how people might be similar, how people might be different. And let's say you really wanted to know about leadership. That's probably more with personality type than astrology sign. You never know, but that's how you can use these clusters in ways that you would want to, you know, give people advice. So that's just one example. And like I said before, feel free to interject at any time if you have questions. I've kind of done a little bit of an introduction here. And so now I kind of want to dig deeper for us. And I want to see what you guys think about a little bit of a challenge of, okay, these are clusters we know of. We know of star sign and we know of personality types. But now let's bring it back into the health sphere. This is what I do. This is what I'm really interested in. And this is one area where digital phenotyping is very prevalent and a very new technology. And so I have a challenge. We have 5 individuals here. They're all males between the ages of 18 to 25. We are going to know their age, their resting heart rate, their average daily steps, and their average daily hours of sleep. Our goal is to cluster these individuals into less than 5 groups, because there's 5 individuals. You want to somehow put them together to provide generalized advice to improve their health. So does everyone kind of understand what we're doing? You might want a sheet of paper for this one. It's not going to be too much writing or anything, but it's mostly just to get you interactive here. What do you think? It's all your perspective. There's no right or wrong answer here. So here for Mateo, Liam, Elijah, Chris, and Patrick, we have their resting heart rate. Like I said, their average daily steps. You can see the key on the side if you forget what each of them mean. But just looking at these individuals and the information I provided, I want you to try and put the 5 individuals into less than 5 groups. So I'll give you a second to look at this information I provided. Tell me what you think. If you have any questions while you're doing this, I'll give about 30 seconds. I'll use my Fitbit to kind of time you. And like I said before, there's no right or wrong answer here. So keep that in mind. And once you're done, I just started a poll, and you can say that you're done and kind of how many groups you put them into. So like I said, no right or wrong answers. I'll wait a second now.
So again, Bryn, the poll is blocking the info. Well, I guess you can move. So you can actually move the slide if it's blocking. You can move the poll so that you can see the full slide.
Just going to give another 15 or so seconds. And if you're not quite done, totally okay. And like I said before, we're just trying to group them. Let's say we wanted to give them some health advice. How might we, if we only could give 3 pieces of advice, but we had 5 individuals and we can't give them each their own advice to improve their health? Good, great. So I'm seeing more and more people kind of put in their responses. Totally awesome. Okay. I'm going to keep moving forward. So like I said before, we had these 5 individuals. I saw some people made a group of 3. Some people made 3 groups. Some people made 2 groups. One made 1 group. It's a little bit tough just looking at data to cluster people, right? And this is when we just have 5 individuals. Let's say you're Fitbit and you're trying to provide health advice, but more personalized for each individual. It's really tough to just look at it like this. So now let's kind of see how else we might be able to look at it if we had more information about what makes someone healthy or not healthy. And so here we're looking at their resting heart rate, which is that top level here. And here we have from the internet some kind of clusters of what is categorized as, above average resting heart rate, excellent level resting heart rate. And I just want you to kind of look at that as you've written down and say, what, categories do each of these individuals just for their resting heart rate kind of fall into? Because once we can kind of categorize it past the number, we might be able to get a better understanding. And this is something we do with digital phenotyping, is put some context to numbers. And so we'll do that through this little exercise. And so I'll give just 15 seconds for you to look at this. And I'll have all this information as we keep going through the slides. If you miss something along the way, you're not missing anything. I've got all of it here for you. So you're right there along with us. I'm just kind of watching to see. Okay, looks like we're kind of ready to keep moving forward. So here I have the resting heart rate scores that I got from that table, just in case you didn't look at them all in time. So we see kind of these different categories that Mateo, Liam, Elijah, Chris, and Patrick fall into for resting heart rate. And so now we can kind of store that in our memory. Maybe we'll be able to use that later to make better clusters. And so now we're going to look at their average daily hours of sleep. I hope you guys are getting enough hours of sleep. You can kind of think, I don't know if you guys know these metrics about yourself. Since I'm really into wearable sensors, I definitely know these metrics about myself, but maybe this will make you curious and you'll want to know, how many daily steps you take and what's your resting heart rate and average daily hours of sleep. So good to kind of think about these tables as you're, thinking about you. And how many hours of sleep you maybe get. Maybe it's less than 5 and maybe you should get some more sleep at night. I know sometimes I've been there too. So just trying to think, do Mateo, Liam, and Elijah, and Chris, and Patrick get enough sleep in this scenario? So it looks like for about half of them, they're getting enough sleep. But for Patrick over there, not only is his resting heart rate not in a good kind of category, but he's also not getting enough sleep. And Elijah, he seems to be getting a little less amount of sleep than might be appropriate. It may be still appropriate, but it's slightly on the lower end. So we're seeing kind of he's not fitting into, the same category as everyone else with sleep score. And so we can kind of keep moving forward. And I won't spend too much time on this, but we can do the same thing with steps. And steps are kind of my favorite thing. I think getting moving every day. This is my shameless pitch about getting more steps in. I think it's really important to really get your body moving every day. So if you don't feel like you're getting active every day, maybe this is a good goal for you to set for yourself. I'm a big supporter of that. So as you're looking at this, which individuals do we see not really getting enough steps and maybe is on the lower end of the activity scale? And how does that correlate with other information we found about, Liam or Patrick or Chris? So here, we're just going to look at this again, and then I'm going to put up a poll. So if you remember before, I asked you to make kind of groupings of if we wanted to give health advice to these individuals that kind of fit together, how would we do that? And I just gave you a bunch of numbers, and numbers are really hard to look at. But now when we see it kind of in this table format for each of our users, does that make it maybe a little bit easier? We see that Patrick, not only has a poor rating of resting heart rate, but also isn't very active and isn't getting enough sleep. We see that Chris, on the other hand, is got an excellent resting heart rate, is very active, and gets enough sleep. And so we already see kind of two groups forming here. And maybe if we wanted two groups, we could kind of categorize it like that. But we also see some kind of in-between groups forming where somewhat active, and an okay resting heart rate, kind of that stuff. So I'm just going to quick put a poll in just to make sure everyone's still with me here, and say, I'm just seeing this table and making the groups again. Did you change your groupings? And there's no right or wrong answer. It's just saying, it might be easier to look at it with categories when we put context to data rather than just looking at data. And keep in mind, this is only 5 individuals. And so I see a result that someone did change their group. I'm curious about the other 2 of you that I know created groups. Oh, we got another one, and one kept the same group, which is totally cool. Totally cool either way. There's no right or wrong answer. Sometimes looking at data is a lot easier to do when it's in categories. And sometimes when it's only 5 individuals, looking at data and just looking at the numbers is good enough. Which is really great. So I got several responses. The larger proportion changed their groups, but some did keep the same group, which is great. So let's keep moving forward. So we can kind of see these categories here, and we got from the numbers to these categories. But let's say we were going to do some statistics, and I'm not going to go into deep math stuff tonight. It's a Tuesday night. We're kind of tired, but let's say, I'll walk you through it. Let's say we were going to make this an equation to put people into groups without visually doing it. So we remember these tables. We've seen them. They're very familiar. Let's put a number to each of these categories where let's say we're talking about the step 1. If they're inactive, it's a 0. If they're somewhat active, it's a 0.33. And we want it all on a scale of 0 to 1, where it's not just 0 or 1, it can have numbers in between. If they're very active, it's a 1. So just putting them each into scales. And that's what we'll do on the next slide here, where now we have the RHR, which is their category, and then I give them a numeric rank. And that numeric rank is what we're going to use to kind of give a score to each of these individuals, which might be able to help us cluster them easier. It's just a new way of kind of looking at it, where we're not looking at resting heart rate of 54 versus resting heart rate of 72. We're looking at resting heart rate of a 0.9 or a 0. So that might make it a lot easier. So here we just sum up their numeric ranks, and there's a lot of things you can do with statistics. Obviously, summing is not, the most complex, but just for this practice, that's just one example of how we might be able to put these people into groups, seeing how different they are with just weighted scores being summed together. And we can see here, how do these scores kind of look? Let's say we wanted to, any person that's in between 0 and 1, that would be Patrick. And then 1 and 2, that would be Elijah and Mateo together. And then 2 and up would be Liam and Chris. And that would be our 3 groups. Maybe that's, not very healthy, medium healthy, and then healthy. And we really want to focus our holistic advice and our health improvement advice on our unhealthy to medium healthy group, where we know that our top group maybe just needs to stay consistent, and we just tell them to stay consistent, rather than telling them, okay, you need to do 5 more days in the gym, and maybe overwhelming them to go back on their own health goals. If they're already doing a lot, you don't want to tell someone to do more and overwhelm them. You really want to personalize those health goals, just like a doctor would do in the office, where they're saying, do eat your veggies, and you already feel like you eat your veggies, and they say, you're not eating enough veggies anyway. How does that make you feel? It's not very personalized. And so that's the whole goal here. So that's one way of doing it, where we look at non-binary numeric ranks. So another thing we do to kind of simplify things is just giving things a 0 or a 1. And that's something I wanted to show you here, where we look at kind of a binary numeric rank, where instead of doing things on a scale, we just say yes or no, active or not active. So if they're not inactive, they're somewhat active, active, or very active, they have a 1. And then if they're average or above, they have a 1. If they have enough sleep, then it's a 1. And here we can see on this next slide how that kind of changes the ranks. It doesn't change it a ton, but it definitely takes away some information there. So you can see how being more clear with your data and how you rank things in your statistical process might be really convenient. And also understanding, not only was, if you remember back when we were looking at this, Chris and Liam, they're both kind of in that healthy realm, but Liam and Chris are definitely very different. But if we do this binary scaling, they're considered the exact same. And so that's where adding more information, making sure we're ranking things accurately, being more clear, and providing as much context as possible when we're clustering people through our different statistical mechanisms, being more statistically significant with our digits and not being as general, can be really helpful in making sure we're providing the best personalized advice. So now I have another little poll situation. I like these. I like to see when people are following along. I'm talking about my passion project, so I hope you guys are at least a little bit curious and like to kind of see where your mind goes with this. And again, for this one, there's no right or wrong answer. It's just hearing what you think. That's why the title of this presentation included the word creativity. This whole process, and why I love it so much, there's so many ways to look at health data. There's so many ways to figure out how we can improve human health. And just like this problem so now for each group, you collect the same resting heart rate, average daily steps, average daily hours of sleep metrics for an entire year. And you want to see how they're changing over time. And now you're seeing that Elijah, who's kind of in our group 2 here of our medium healthy, joined a step counting challenge with his friends. And he started taking many more steps per day on average over time. And his resting heart rate has started slowly lowering on average. If Mateo, who's also in his group, wanted to become healthier, would you suggest to him to start making more steps? And this is kind of showing, would you want to use these clusters that you've put together here? Is that what you would do intuitively, or maybe would you not? And so this is totally your perspective, your opinion. And I'm going to put a poll here to just see what you guys think. Would you use your clusters you've made, or would you not? And there's a little bit of description here of maybe why or why you wouldn't. And if it's an other, feel free to speak up. Feel free to say, I did, but this is why, or I didn't, and this is why. And I'll just give it a couple seconds here, and yeah. Great. So we got a lot of responses. And so here, I'm gonna try and share the results. Can you guys see on screen what's going on there? So it seems like one person said yes, because being active is always a good helper for your health, which love that response. Yeah, being active is always good. And maybe you would want to suggest that for everyone. But several of you said yes, because Elijah is in a similar health cluster and that worked for him, which is kind of the whole point of digital phenotyping. I wasn't trying to like lead you there, but that's kind of the whole point of what making these clusters are for. We're trying to find people that are similar and give them goals that are similar that work for other people in that group. So that's great to see. Let's kind of keep moving forward. I have another little challenge. Not really a challenge, more like a, what's your thoughts on this kind of thing? I don't know if there's a word, a mind scraper maybe. We have a new 21-year-old boy named James who's joined our holistic health suggestion group, and his metrics give a score of 1. So he doesn't fit with Patrick, he doesn't fit with Mateo and Elijah's group, and he doesn't fit with Liam and Chris's group. What would you do with your clusters? And before I as I get the poll set up, feel free to think about this for a second. We have someone new that doesn't fit into any of our groups. Where would you put them if this is kind of your system you were using? And like I said before, no right or wrong answer here. And I know one is kind of long, so you might have to put your little mouse over it to read the whole answer. And feel free to think about it for a second. You don't need to rush to a response. We have plenty of time. And if you want to kind of think about it a little bit more, that's totally okay. Great. So we got our same number of responses that we've kind of been working with. And we got a variety, which I think is really interesting and also really shows how flexible and malleable this whole technology and this technique is of creating these clusters. And so one individual said that they would want to make a new cluster for James, which is very reasonable. We don't have any information about, what advice we should give him. We don't have anyone else that's kind of been in this category that we've been collecting data for a year. How can we start giving advice that might be more personalized for him if we just throw him into another cluster that maybe isn't for him? So they would make a new cluster for James. We've got another individual that says they would put James into the red cluster, which, would be the safe option. That's also a great response. Like I said, no right or wrong answer. And that's with Patrick. And so without knowing anything, you just assume that he's maybe on the lower end of the spectrum of the health, and that you would give them more advice that could improve their health. So that's also a great response. And I can see how that could definitely be something you would want to do. And then we had some other individuals that said that they would recalculate with new metrics or weights to make James fit into a pre-existing cluster that you have already gathered group metrics for, which is also totally a reasonable response. As you saw before, we created these kind of numeric rankings, and you can always weight those rankings based on different things. Let's say you really know that step count is a big indicator for health. And so now you're going to weight that a little bit more so that you can make sure everyone fits into one of your 3 clusters. Or that resting heart rate is a big component of something you want to give advice on improving. And so you really weight that one by just kind of multiplying that that numeric rank by something else to kind of give you a new formula that's putting people into new groups. And so recalculating new metrics is definitely something we do. All of those 3 responses, and even the one that no one chose, are options that we do within the technology and within the field. It's, we might put them into a pre-existing cluster, we might make a new cluster, or we might redo the whole thing to make sure that we can re-put people into clusters that we are accurately making clusters for. And so I think it's great that we had a variety of answers, because that just shows we do all of those things. Still moving forward, let's just kind of talk for a second about what we've observed. Classification of clusters is tricky. Just like we saw in that last one, when we have a new individual that joins our, algorithm, our system, Fitbit has a new person and their data is totally different from everyone else. And they're like, who is this person? This can't be an anomaly. Maybe it is. Should they start giving personalized metrics just for that, or personalized advice for just that individual? Or should they make sure their algorithms are fitting every individual in their population? And so classification of individuals and their health metrics can be really tricky. And there's a lot of different fun things you can do with that. Another thing we've seen is that visual classification of small groups of data can be much easier than large groups of data. We saw 5 individuals with 4 kind of layers of information that wasn't super clear to see. And that was just 5 individuals. Let's say we multiplied that by 5 more and had a whole classroom, and we were trying to put that classroom into clusters. You can understand that would have taken a much longer time than me just saying, okay, now put these into groups less than the number of individuals in here. That would have taken a while. And so visual classification, can be easy. It's still a little tricky, but with larger groups of data, even if I would have multiplied that by 2 and said for these 10 individuals, put them into a group, that would have been tough. And so that's where using statistics and machine learning and kind of different technologies is really a big use for us. And we don't just do things like we were doing today with our eyes. That was just for us, to see what that might look like, what's going on under the hood. And then creating clustering models can range from very simple to very complex. We kind of saw that as we took our raw signal and then we applied a category to it based on contextual information that we knew. And then we applied a new rank to that category that we had. We took it from a number to a cluster or a category, and then we took it back to a number that was on a scale that we could understand and process quicker. And so that was a relatively simple process, but we can go through many statistical steps to make it way more complex if we wanted to, or if the data really needed us to. And so that's where I want you definitely to understand it's not always kind of this simple, but it can be. It really can be. So it really depends on your problem, and that's where creativity and someone being, interested in how can we solve this problem is really the key to this entire field, this relatively new field. So let's talk about a little bit more about how it might look if we weren't doing this, visually. Let's investigate a little bit further. And so, like I said before, when someone didn't fit in the group, we had James, who just entered the party, wanted some holistic health goal making with us. How did we, put him into a cluster? So statistically, we can look at that as an examination, an isolation of markers specific to cluster goals. Just like I was talking about, if we had step count being really important, or resting heart rate being really important, and we can define clusters like that by weighting it very differently. And we can do the same thing for people at risk for lung cancer versus less at risk. We can look at, okay, are they a smoker? That's a yes or no. Or are they a daily smoker versus weekly smoker versus monthly smoker? That's where we can have those different at range numeric classifications. And then we can look at other things that might contribute to lung cancer prevalence or existence. Where are they very active? Or do they have a pre-existing kind of concern for that through their genetics? Does someone else in their family have it? And so you can look at these different things, because the amount of sleep that they're having might contribute, but doesn't contribute as much as how much they smoke or how much they engage in risky behaviors. Maybe not, you'd have to look at the research, and maybe that's something you want to investigate, is how much does sleep really influence these, health problems? That maybe that's the answer. But you're probably going to want to weight the things that you're really confident about. So that's where isolation of markers is something we do statistically and kind of rank things. We can also look at anomaly detection. So like I said before, in that Fitbit example, where you have, all these users of Fitbit, and then all of a sudden Fitbit gets a new user and they're like, wow, they don't fit into any of our groups. Is this an anomaly? Maybe, but how they go through that anomaly detection is looking at, okay, what are our usual ranges for everyone, but also these groups that we put people in. And if let's say me and I take 1 million steps a day instead of 10,000 steps a day, it's a totally ridiculous example, but, I just don't fit into any groups. Statistically, you can find, I'm sure you've heard of maybe standard deviation or outliers or those kind of things. You can find outliers within your data set of everyone in your whole population. And, reasonably, no one's going to have a resting heart rate of 20 beats per minute. And so that's going to show up as an anomaly. But let's say you have someone that's got a resting heart rate of 150. It's possible, but that's an anomaly, and we should definitely give them more health advice. And so that's where we can do some statistical outlier detection, which I'm hoping you've heard of in your stats classes. And if you haven't, you'll probably learn about it soon. And then we can also do something called principal component analysis. So if you guys have ever been to the doctor's office and they ask you about a million things about your health, when is the last time that you slept? How much do you eat of this? And how do you feel about this? And they take all these different vital signs. That's going to create a lot of kind of rows in that table. If you remember that table of just, 5 individuals with 3 metrics about them. But imagine all of your information over the last 10 years of your life. That's a lot of information. That's a lot of rows and columns in that big spreadsheet that, you can imagine is you in a medical health data set or in your electronic medical records. And so we can use a system called principal component analysis. There's a lot of different systems that are similar to principal component analysis, but I just wanted to talk about this one because I think it's kind of the easiest to understand. And also the name makes the most sense. So we call all of those different metrics features, and you can also kind of put metrics together and create new features from that, which is called feature engineering, which I won't get into, but if you're interested, you should look it up. Also very interesting. But you can look at all of these features, all these metrics, all these things about a health data set. And then you can do principal component analysis, which is just going to find the features that are leading most or most contributing to a certain thing. And so whether that thing is a diagnosis or pretty much you're looking for which metrics are causing or having the most influence on a certain other metric, or where are they most correlated. So you're looking at correlations between features, and maybe, like I said before, if you're looking at lung cancer, is sleep the thing that's, most related in all of these incidents of people who get lung cancer, or is it maybe smoking? And so if you did principal component analysis on a bunch of instances in a data set of people who eventually get lung cancer, probably smoking is going to be one of those principal components that it extracts and tells you, okay, look at this metric a lot more and weighted a lot heavier. So it's just a way of looking for what are correlations between metrics that are very similar across other different individuals, especially when you have a specific diagnosis, condition, or quality that you're looking for among health data sets. So and if that didn't make sense, that's totally okay. It's a totally new kind of algorithm, but it's just an example of how we can use, we can weight things, we can find what's different among different people, and we can also find what's similar among different people. And so that's kind of 3 ways you can look at different statistical analysis you can do. And I didn't want to get really into machine learning stuff, but I think it's really interesting. And I also thought these visualizations I found online were really interesting too. And so if you're interested in kind of how you would cluster, but not visually, obviously, we don't usually do that in the field very often, you can maybe look up k-means clustering. And this is kind of, one of the most typical clustering mechanisms in machine learning. And if you don't know what machine learning is, it's basically, if you've heard of code, right? And usually you teach code, if you have this happening, then do this. If you have this happening, then do this. And you're really telling a computer what to do, which is really interesting. But machine learning, it's supposed to really make its own decisions. And that doesn't mean like AI, yes, machine learning is related to AI and robots, but it's mostly about having a computer program kind of going through its own decision structure. And so that's where that relates here to clustering techniques, where we don't want to tell explicitly the computer or the program who is in what cluster. we wanted to look through this range of data points and to, cluster it themselves. And so k-means, you can kind of see what it's doing over here. It's looking for the center of different sets of points. And you can see how, as the color changes, it's trying to find where those clusters are. And you define how many clusters you're trying to make, and it'll try and kind of group it itself. And I think I could go through that algorithm on the side, but I think just looking at this picture where those X's are moving, trying to find the center of the different groups and changing the color based on that gives a better example of how it's trying to find the group center and putting it into groups. So if you're curious about clustering techniques, maybe look into k-means clustering. If you want to learn more about kind of the mathematical side of what I'm discussing today, because I've been pretty general and just trying to get your mind kind of brewing a little bit, kind of ruminating over what could be, what do I do here? How could I get involved? Another one is agglomerative hierarchical clustering. This is big words. Don't be intimidated. It's okay. It's just a different clustering technique. So here, if we were just wait until this animation starts again, you've got a bunch of these different points, and then it's going to look for points that are most together on your kind of data frame, right? That's if you were to just graph everything and put it on a kind of a scheme like that. And then it's slowly going to put people together into different clusters. And you can see here at each layer of this tree, it almost looks like a tree over here. It's called a dendrogram. You can stop your clustering at any point. Let's say you wanted to have 3 clusters. You wanted to have 2 clusters, you could stop here. If you wanted to have 1 cluster, you could stop there. Why you would have 1 cluster, it doesn't really make sense. But that's just another way you can find what's similar between these data points and how do they correlate together. And this is just another algorithm that's very common, that if you're curious and you want to learn more about the science, this is one you can look into, is agglomerative hierarchical clustering or bottom-up clustering, that I just wanted to get you guys a little bit more familiar with, at least by here is a term. And so we've gone through a lot today. We've kind of done our own digital phenotyping algorithm, but just visually and kind of with each other without, having to do the code for it. And we see that there's a wide variety of applications. We can use data from exercise, from activity, from sleep, from social. And I've talked a lot about the health aspect, but you can use digital phenotyping for anything, where you're just trying to understand how people are similar or how things are similar. It doesn't even have to be people, and how you can do more things to help them, to make better understanding, to make better goal setting, to have better behavior for whatever thing you're trying to interact with, whether that's you're putting animals into groups in a zoo and you want to understand like how to allocate resources, or it's humans and you're trying to provide health data. There's a wide variety of applications for making these unsupervised clusters. It's called unsupervised because you're not specifically telling the computer what those clusters are. And then there's a growing number of data streams. Like I said in the beginning of this chat, we've got our phones, we've got our Fitbits, we've got our Apple Watches, we've got our TVs, we've got our smart refrigerators, we've got all these different data streams every day that, we are getting lost in it. But we don't have to get so lost in it. We can really use these signals to learn a lot about ourselves, about our communities, what makes us similar, and how we can become better humans. And so using these streams, we can really leverage it. And that's kind of the whole point of digital phenotyping, is leveraging different data streams to become better humans. And we also know the main reason why this kind of came to be, the main reason why the Onella lab at Harvard really coined this term and started making it very prevalent within my area and my field, is the growing need for digital health solutions. We've all kind of experienced in this last year, 2 years, 3 years, 4 years, the need for more digital health-based services with taking telehealth calls, taking, I want to use my Fitbit to track my health more and understand more about my health so that it's not in someone else's hands, or, wanting to be, better for yourself and not for anyone else without having to go to anyone else, either because there's not enough accessibility or because you're an independent person and you can take control of your health and be independent. So there's a growing need for digital health solutions for prediction, diagnosing, monitoring, intervention that should be accessible to whoever wants it without having to go into an expensive health provider or get an expensive app. And so that's where knowing about these things and starting to think about these things, especially at your age where you're, just coming into the field and this is the landscape. We need your minds to come up with cool, innovative ways to think about problems within the health sphere, but also outside the health sphere. And so that's what I want you to really think about is, okay, maybe you remember nothing about digital phenotyping, and that's okay, but you remember there is a growing need for a variety of technologies. There's a growing need for a variety of thoughts, for ideas. And that's kind of the whole point of this concept of digital phenotyping is someone thought we need something new. We need a new way of looking at this. And I hope, you think about that a lot as well. And so now I'll kind of hand it over to Lauren. Oh, yes. And she just put in the chat, create your own invention contest. That's exactly what we're talking about. We also have the Science Olympiad at the end of this year too. So if if your school is getting involved in that, there's a lot of ways to get involved with coming up with new ideas and really pushing yourself. And if you have any questions about that, there's a ton of people within this sphere that are willing to help. I was in your shoes only a couple of years ago, and golly, I love to have chats like that. It just brings me life to just see what your guys' ideas are. So now I'll kind of open it up to Lauren, and I appreciate your time.
Yeah, so thank you, Bryn. Hopefully you all have some questions for Bryn. I'm going to give you a minute to think about your questions. You can either put them in the chat or unmute yourself, but I'm going to launch just one last poll. There are 2 questions just to give us some feedback. Rating the overall experience tonight. And then the second question is rate your new knowledge. Did you learn anything tonight? So 1 is the lowest, 5 is the highest. Just going to give you a minute to answer, and then we'll go to questions. Because I know this was all new to me. And as Bryn said, it's a new field, but I'm hoping maybe some of you have some questions. All right, I'm going to give it about 10 more seconds, and then I'll close the poll and we'll go to if you have any questions. All right, I'm going to end the poll. Thank you for that, everyone. And who has questions? Unmute yourself or chat. Carly says, what made you interested in this?
Thanks for the question, Carly. I'm really excited you asked that. I really became interested in monitoring human health at a young age. I think that being a better, healthier human is not something that, I want to put into someone else's hands. I think it's my responsibility because I cherish life. I cherish, being a human on this earth. I think, for a long time, I wasn't sure growing up, where my spot was in the world and what I wanted to do, but I knew when I was healthy and when I was active and when I really tried to push myself, academically, but also physically and trying to be engaged, I felt like the best human I could be. And so that's where I really got engaged in this field because I knew, okay, I can be the best human I can be by understanding my human health. How can I help others learn more about their health? Not only their physical health, but actually what I focus on in my studies and my research is mental health and identifying internalizing disorders in children early on by looking at their physical health signals through different activities and trying to provide diagnoses to ages of humans that, can't really get diagnoses because they can't speak about what they're feeling. And so how can we use signals to provide that insight that they need to become healthier humans later on? And so it started at a young age and it's just kind of persisted. So is this
kind of like a doctor?
It's kind of like a doctor, but it's supposed to kind of help a doctor. And it's also supposed to be for you at the same time. So a doctor, what they do when you come into the office is you say, oh, I've got all these feelings, and also I've got all these things happening with my body, and maybe you can see these physical ailments, maybe you can't, depending on what you're going in for. And then the doctor tries to provide some insights on, what you should do to become healthier. But let's say a doctor could learn more. A doctor can't spend all their time reading hundreds of thousands of electronic medical records to find all the little trends between different individuals. And so this is supposed to help doctors, look at data quicker, understand quicker what has worked for other people or what might be red flags for other individuals that are very similar to their patients. And so it's like a doctor, but more like a helping friend to a doctor, and also to you and me and to anyone else who might want to learn more and find people that have, just walking 10,000 steps a day, lower my resting heart rate. If that's my goal this year, I want to know, that's kind of the goal. Great question, Carly.
I like that, a helping friend. Any other questions? Again, feel free to unmute yourself or pop it in the chat if there's any questions. Alyssa asks, are there any current apps that use phenotyping?
Yes. Actually, so the Onella Lab has released one that isn't entirely available to the public yet, but more researchers use it. But my research group is actually in the process of creating an app that does the same kind of digital phenotyping of looking at childhood mental health, and so that doctors and pediatricians can use it within the office. And so there's some apps, but it's not entirely available to the public yet. But if you have a Fitbit or if you have an Apple Watch, these companies are doing very similar things of kind of clustering different groups of individuals, providing insights based on that, but it's not, super clear. And so yes and no to that question. Great question.
All right, we are just past our 8 o'clock hour, but we do have another question that came in. So Carly wants to know, when do you have to go to school for when you want to work in phenotyping?
Okay, that's a great question.
What do you have to go to school for? Sorry, I need to read the question correctly.
That's a great question. So my background is in engineering, health, and computer science. It doesn't mean you need to do all three. It means that you just go into a field that you're interested in. And if you find yourself kind of going towards that route, I really recommend having some sort of coding background, because it is coding. But that's where going to like that learn to code event coming up soon to code in Python. Python is the language that I code in. It's not the only language that I know, but that's a really good language to learn. And it sounds crazy learning a language, but there's so many resources online. It's not too intimidating, and there's so many people willing to help. If you guys have a smartphone, I really like this app called Solo Learn. It's free, and you can do little coding tutorials. It's almost like a Duolingo, but for coding and for computer science. And it's totally free. And you can compete with your friends, like with little quizzes. And so if you're interested in digital phenotyping, in coding, in health is really getting more and more ingrained in technology these days. So if you're at all interested in health, go into health, but make sure you can do stuff on a computer. Make sure you know and you have that kind of vocabulary. So that would be my recommendation if you're interested. And I do recommend it. It's great.
That's great. I have Samsung. Is there any on there?
Definitely go on your app store. I recommend it for anyone. There's a lot on different kind of, I don't know if Samsung has Play Store or App Store or kind of what the application store looks like, but there are so many free coding apps, not only on your phone, but also online that you can look into. It's Google Play. Then I'm pretty sure on Google Play, there's going to be a ton. And if you have any questions, you can always reach out to my email. I'll put that in the chat right now. And I'm happy to provide, more resources or answer any questions you have. I'm very available. And what is the code?
And Carly, I'm going to recommend, with all the different engineering and coding stuff that we have going on in February, do the coding class we're having. Come to that event on the February 12th, because there's going to be lots of different engineering workshops and different people that you can talk to and learn about all this different stuff. Because what I heard Bryn say, engineering, coding, and health, it's that intersection of three areas that brought her into this field.
Exactly. I definitely recommend going to those events. I did those events when I had opportunities to, but golly, looking at the amount of events that are offered here, it's way more than I ever had access to. And they're free, you can just go and participate and even earn prizes. And that's great stuff for your resume, but also just for your free time to learn and engage with other people that are interested in it. So I definitely recommend getting involved. And I'm just excited you all are here, and I appreciate you listening and being excited and, taking that time for your education, this would be really great for you to tell your friends to get more involved. But even if they're not here, I'm glad you're here because it shows you're dedicated.
Carly, for the coding. Yeah, let me, you
Can maybe
sign
talk
up.
with Lauren and send her some resources too, that with kind of the coding events, I can send out some additional resources for beginner coders that maybe we can provide. Does that sound good, Lauren?
Yeah, and the coding class can be found at this website that I just put in the chat. The registration's now open. There's a flyer there. So you can sign up at any time. The class doesn't start until February, so you have plenty of time. But with that, I'm going to ask, because it's 8:05 and I want to be respectful of everyone's time. I'll just ask if there's any final questions that you want to ask Bryn. Bryn is going to be around. She's a PhD student. She's going to be at UVM for the next 5 years, and she's volunteering. She's going to be helping out with the Science Olympiad and hopefully some other events. So definitely, take advantage that she put her email in the chat. She is a resource. And someone that you can, connect to. Just if a question comes to you later on, reach out to her. So with that, let's just thank Bryn for teaching us about digital phenotyping tonight, and thank her for her time. And I appreciate you all coming tonight for our last virtual cafe of 2021. And I hope that you will join us in 2022. So everyone have a good night.
Thank you so much. Have a good night.
Thank you. Have a good night.